Resistance heating elements come in many sizes, wattages, voltages. I've got 3 examples here. We have one in the water heater. But we're going to talk about heating elements, 3 distinct styles. Okay, copper-coated element, what I'm going to call the standard element here, just a single loop and back. We have, again, a copper-coated element. I know that based on the black cap here, but with it a longer surface, we refer to this as a low watt density. So you take the same amount of energy that you would have here, okay, and we're going to spread it over a larger distance, so it's not as hot per inch per se. That element tends to last a little bit longer, be more tolerable to a lot of water conditions, harder water specifically. Excuse me. And then we have the green cap, the aquamarine cap, Incoloy element. You'll notice that this too has a little longer fold-back style, low watt density. Okay, but the Incoloy element, different coating. It is much more tolerable to heat. Again, it's going to last a little bit longer. Water conditions are the biggest variable as to which element you choose. You work with your wholesale supplier on that. But how do you test them? In all examples, wattage is going to dictate or lead to a resistance value. It's common in the field. We're going to test elements. A lot of folks are going to set up their meter to measure continuity, the tone, the buzz. Okay, we can do that as well. I set my meter to adjust or to provide the tone. We've got that. My preference and our preference, actually set it to measure resistance. Set it to omega ohms, and to do this, we're going to go from one screw to the other screw. It's going to provide a value for us. Okay, 12.6 ohms. Remember that depending on wattage, depending on voltage, that resistance value will change, right? So if we're working on a 2-element heater, top and bottom elements, on the element itself, we have a voltage and wattage listed on that. Okay, so we can do the math, figure out what it should be. 4,500 watts, 240 volts, 12.6 is what I'm going to expect. Now, if I take another element, say I've got this element here, if I look at the 5,000 watts, 240 volts, okay, so if I measure the resistance here, it's going to be noticeably different because the wattage is different, 11.3. So simply measuring continuity, that tells us if it's broke. Okay, that little wire tells us if it's broke. Measuring resistance tells us, is it in the range that it should be, using the math. Okay, one thing I want to touch on, we know how to test the resistance of the elements, whether it's good, whether it's bad. We also want to be able to test if that element is grounded. So using the water heater example here, of course the power is off. Taking the screw out. And whenever we do resistance testing, we're always going to have the power off. Okay, safety. Got to make sure that's off. So at this point, I'm going to adjust my meter, turn it off, back to measure continuity. Okay, and what we're doing is going to go from one of these screws to the tank body itself. If we have continuity through that test, that tells me the element's actually shorted out. A shorted element is going to heat water continuously. Okay, so I'm going to go to the tank body, to the element. I should not have a tone. Okay, if I touch my test leads together, I've got the buzz. Screwed to ground, no buzz. So remember, that's what we're looking for. No grounding of the element to the tank body, but that's how you're going to test elements. Lastly, and what I want to touch on, very important step, when we're installing an element, it's going to go into the tank, what I say, hand tight, maybe a quarter turn with an element wrench. There's a gasket on this element. That's what's actually providing your seal. So we're going to put the element in, tighten it up, rely on the gasket to provide that seal. When you're tightening your wires, the wire is going to go on the top side of the screw. So you can see as I tighten this screw, righty-tighty, lefty-loosey, it's actually going to pull that wire into the terminal block. So very important step, and that's something that we look for in any type of field return or any type of problem. Put the wire on top of the screw, so as you tighten it, it pulls that wire into the connection point. You can maybe visualize if the wire's on the bottom, as I'm tightening that, it pushes the wire out of the connection. Tight connections, very, very important, anything electrical, but dealing with line voltage and water can never be too safe. Heating elements, any questions, give us a call. iTech is available 24/7.